Hello students, welcome once again, and we have to find a power series representation for the integral of the function. So what we are going to do is that we have the function h of s equal to s to the power 4 divided by 9 plus s squared. So we are going to represent the function in power series, then after which we will find the integral of the function. So let's start. So we have h of x being equal to s to the power 4 then divided by 9 s squared. Now in a representation of power series, I've done a lot of videos on how to represent functions in power series. So if you haven't checked on that, just look at the screen above there, or you wait and the end of the video, it will be on the screen, then you can watch that. So in a representation of functions in the form of power series, we have I've grouped it under 3 steps. So the first step is that you must write your function in the form 1 over 1 minus x. So writing this function in the form 1 over 1 minus x, then we can have that. Now over here, I'll factorize s over 4, s to the power 4 out, so that I can have 1 over 9 plus s squared. Now we still haven't represented it in this form because we have 9 over here and it has to be 1. So what we are going to do next is that we are going to divide all by 9. So we have s to the power 4, then we can have 1 over 9 here, then 9 over 9 plus s squared over 9, so that we can have x to the power 4 out, so it will be divided over 9 here. Then we can have 1, we can have 1 here, then 9 will cancel 9, then we have this here over 9. Now we are halfway through because we have 1, then we have 1 here, we have 1 over here. But if you look at this place, we can leave this side just like that, but it is negative. So how can we represent this in terms of negative? So we have s to the power 4 then over 9, then we have 1 over 1 here, then we can minus, then also another minus s squared over 9 over here. So minus will still give us positive, and therefore the value of x over here is just that. So that's just the first step. Now the second step is that, so we have h of x being equal to this. Now the second step is that we must represent it. We must in terms of this, we must find the value of a and the value of r. So comparing this to that, so comparing all of this to h of s, you realize that the value of a is 1, then the value of r over here, so the value of r over here is just we have r to be negative x squared over 9, because r is just, so this is this negative, and the r here is just minus x squared over 9. So we have this. Now the last step to do is that we must write it in a form of the summation as infinity n go n equal to 0 ar to the power n. So we must write it in terms of that. So let's do that. So therefore we can have h of s being equal to, remember, s squared, then 4 out here, then the summation of a is just negative s squared over 9, then r is just 1, we have r to be 1, then to the power n. So putting this inside, then we can have summation of negative 1 here, then we can also have s squared over 9, so we can put the n here, then also we can have x to the power 4 over 9. Remember, this 2 is to the power n. So we have this, and from here we can have negative 1 to the power that, then we can divide over, the n is for both, is multiplying each of the exponents, so we can have 9 to the power n, and there is another 9 here, so it's plus 1. Then we have x 2n plus 4. So basically this is what we have for the representation of the function in power series. Now the next thing to do is that so we have the function h of s being equal to the summation of us. So we have negative 1 to the power n, then divided by 9 n plus 1, then also x to the power 2n plus 4 here. So this is what we have. Now what we are going to do next is that we are going to represent the function. We have to find the integral of this function. So we are going to integrate the function in terms of x. So we have the integral of that is just the integral of the summation infinity so the integral of this, then we can have negative 1 to the power, that's 9n plus 1, then 2n plus 4. So to find the integral of that, we just have this to be remember dx. So we have the whole of that, and this is what we are going to base on because we are differentiating with respect to x. So we have x over here to the power 2n plus 1. So in differentiation, what you do is that you drop this whole thing. So let's drop it, n plus 4. Then after which we have the whole of this. We subtract 1 from it. So we subtract 1, we have 2n plus 3. Sorry, we add 1. So when we add 1, because we are integrating, so so the whole of this divides 2n plus 4. In differentiation you drop it, but in integration you divide by the exponent, then you add 1 to the exponent. So when we add 1, we have 5 here, then plus c. So we have the integral of this whole thing just to be the integral summation infinity 0, then we have negative 1 to the power n, then 9n plus 1, then we have x 2n plus 5 divided by 2n plus 4 here, then plus c as our final answer. So basically this is what we have. Thank you very much for joining me in this section, and we'll meet for another section.